Hi, in this video, we will discuss how to perform the LU decomposition and use it to solve the inverse problem. In this example, we have three equations that has been converted to the matrix format, and we are going to find the unknown x by using the system matrix A and right-hand side function B. In the LU decomposition, we are going to decompose the A matrix, which is the system matrix, into a smaller component. A matrix is the multiplication between the matrix L and matrix U, and L matrix is the lower triangular matrix, and the U matrix is the upper triangular matrix. So this is one example for the LU matrix, where you have the lower triangular matrix and upper triangular matrix here. So for the upper triangular matrix, you see non-zero at the upper part, and for the lower triangular matrix, you see always 1 at the diagonal component and non-zero component at the lower part. This is the result when you multiply between these two matrices. For example, if you take the row here, multiply with this column, then 1 multiply 3, you obtain 3 plus 0 and 0. So this is the result for the first element here. So you obtain 3 here. If you continue to take this row and multiply with the second column here, so you see 1 multiply negative 0.1 plus 0 multiply this plus 0 multiply this. So you obtain negative 0.1 here. If you continue for the last column with the first row here, then you obtain negative 0.2 only. You can continue the process for the second row with these 3 columns, then you obtain these 3 results. And continue for the last row, multiply with these 3 columns, you obtain these 3 results again. So this result, when we compare to the A matrix here, you see the discrepancy is very small. It's almost similar to it. This is due to when you perform the calculation, there is some round off error. So we can say that our matrix A, by using the LU decomposition, we can success to find the lower matrix multiplied with the upper matrix, give you the A matrix. The question is, how can we find the LU matrix from the A matrix here? In fact, we can find the LU decomposition result, which is the LU matrix, from the previous Gaussian elimination result. This is the same problem that we have used the Gaussian elimination to solve it previously. After you perform the determinant analysis, scaling analysis, as well as the pivoting strategy, we can continue with the Gauss elimination or the Gaussian elimination. The blue color matrix here represent our system matrix. So after you perform the forward elimination, and then you should obtain 0 at these 2 elements. This can be done by using these 2 factors as well as these 2 equations. We continue to eliminate this component into 0 by using the second forward elimination. This can be done by using this factor and this equation. From the Gaussian elimination result, then we can find the upper matrix and lower triangular matrix. Your upper triangular matrix can be found from here, which is this system matrix after the forward elimination. Then you can continue to find the lower triangular matrix, where we let the diagonal part to be always 1, and then the first factor that you use to make this element 0 can be written here. The second factor that you use to make this component to be 0 is written here, and the last factor that you use to make this component equal to 0, like this, is written here. So you see the factor that we use for the forward elimination is written here to form the L matrix. This is how we perform the LU decomposition by using the previous Gaussian elimination result.